We want to reproduce the behavior of our system. So we need to get started and make things happen. If we were sitting in a place watching to our gas station, the first thing we could see would be a customer arriving to our system. And we know, in addition to that, that 90 minutes from the beginning of the working day, the operator will have a break. That's why within this event list, we first need to create an event for the customer arrival, for the first customer arrival, and then we have to create this event, which is the start time for the operator break. For us to get this time here, we would have to do something similar to what we did with the Bob and Ray example. We would need to generate a random number, and with that go to an exponential distribution of mean 2, and instead of using those tables, use the inverse function of the probability of that exponential behavior and get this value. I just made this number up, but there are ways to get this a number, which is 3 minutes 13 seconds, which is the time for the first customer to arrive after the model starts running, which is the moment when the gas station starts to operate. So these are the two first events that we know for sure are going to occur. So the next step is to move the clock forward. So we have identified two events, the customer arrival and the operator break starting time. So that we know that in between 7 o'clock and 3 minutes 13 seconds, nothing is going to happen, because nothing will change once we've started we've started our model to run, which is equivalent to start with a working day. Nothing will change until we have the first customer arriving to our system. So we move the clock to that instant in time, and we see that we would have a car arriving to our system. So what we expect to happen if we made a detailed simulation is, first, this car would check if there's place within the queue. Since there is, it would get into the queue. Once it gets into the queue, it would check if there is place in either of the two dispensers, which is the case, and it would eventually move to the dispenser. And what we would see, what we would have to do is to change the state. Okay, we would have the operator busy, and we would have the dispenser one filling, and as well first busy and then filling, because we are serving this customer. And we would change the state here to get a good picture of how things are at this moment. So notice that right before all this happened, we had the operator was idle, both dispensers were free, and the queue was empty. And all these things happened, and right after that, all those things happened, we have these states here. Okay, so we need to keep listing our events to make sure that when things are supposed to happen actually happen. So what we know is that we are going to generate new events, and that means that if we started filling a customer, or we're serving a customer, the next event regarding that customer is that it'll be filled, it'll be served, and the filling will finish, and it'll be ready to leave the system. And second, once we have had one customer arrive into our system, we need to schedule the next customer to arrive. So for the first thing, we know that there's a uniform distribution ranging from 3 to 5 minutes for the filling time. So we would get a number following that distribution, and we would add that value to the beginning of the filling. So we have this value for the filling, which in this case is 3 minutes 5 seconds. And since we need to program the arrival of the second customer, we would generate another value following an exponential of 2 minutes on average, and that is this 4 minutes 10 seconds. So if we add these two values, these two times to the current time, we have these other times, which are the end of the filling of dispenser 1 and the customer arrival corresponding to second customer in our system. So now what we have is we've moved the clock till this point, and we've generated the two next events to happen. So now we know that there is nothing that will change from this time to the moment when the filling is done, because there won't be any new customers arriving and nothing else will happen. So we can move till that time. So we move to 7/6/18, and the end of filling of dispenser 1 finishes. And what we expect to happen, okay, is to change the state according to this filling finishing. So the operator gets idle, the dispenser 1 is free, and the customer leaves the system. I haven't logged the fact that we have some income. I'm just simplifying that, but we'll register that so that we can eventually have our income to compare that with our costs. And once this customer has left the system, nothing else occurs until the next customer arrives. So we move the clock till 7/7/23. Okay, we do that, and we are now at 7/7/23, and the customer arrives, and we do exactly the same we did before. The customer tries to access the queue, which is something he or she can do. And then the car moves to the dispenser, which is available, and we will assign the operator to the dispenser. And we'll have the operator busy and dispenser 1 filling. Again, now we have updated our states, and we have the operator busy, dispenser 1 is filling, dispenser 2 is free, and the queue is empty. And we need to generate the events, this new event generation, because we have to schedule the arrival for the third customer. We generate a value following an exponential of min2, which is in this case 1 minute 13 seconds, and we have to generate a value for the filling time and have our end of filling. So we're supposing the filling will take 4 minutes 10 seconds, and the next customer will arrive in 1 minute 13 seconds. So that leads us to having these two new events. We have 3:8:36 the arrival of third customer, and we will have at 7:11:33 seconds, the tenth of a second, we will have the finishing of dispensing or serving the customer which is in dispenser 1. Okay, so again, nothing happens between these two events or between these two times, and we can move the clock till 7:08:36. And when we do that, what happens is we have a new customer arriving. Okay, and when the customer arrives, he tries to get into the queue, which he or she can do. Then it won't be possible to get to dispenser 1, but the car will be able to move to dispenser 2, which will happen. And instead of having the operator assigned, what will happen is that dispenser 2 will be awaiting for the operator. And as soon as this operator finishes with dispenser 1, it'll move to dispenser 2 to serve this customer. And so it goes, so that we reproduce the behavior of the system, and we keep track of everything that happens. And I'm not getting into all that detail, but you can compute the time that dispenser 1 has been busy, and the time it's been idle, or it's been waiting for the operator to arrive. So we can finally add all those values, divide that sum by the total time, and get the percentage of every single state. You can see how much have you been using the dispenser, or how much time it's been idle or it's been waiting for the operator, so that analyzing all those results, you can make decisions regarding whether you should have more dispensers or more operators.